Hi folks, we're in Module 3 now, and I'm looking at the Novice Problem Solutions 1 and 2. Let's take a look at these problems. This is our chapter on probability, really important in understanding uncertainty in the world, and one that we should really take more of a practical interest in than just a theoretical interest. It's not just theory, it's about what happens in the world. We've got a problem that has two data elements, an initial contact and a resolution time. And we sum those two values to determine for a customer the total time required to interact with our service, our help service. So now we have to determine first the number of random variables that we have, the unique random variables. And since we have three different initial contacts and three initial resolution minutes, we're going to have 9 possible combinations. Now, some of those combinations may repeat. So you don't have 2 random variables there, you have 1 that's repeated. So 7 and 12, 7 and 22.5, 7 and 29, those are all random variables, 10 and a half and 12, 10 and a half and 20 and a half, etc. All possible combinations. So how do I do that? What are the combinations? Well, here are the 9 combinations that I got. 19, 22 and a half, 27 and a half, another 27 and a half. You can see I put it in the same shaded color. 31, that's unique. 36 occurs again. So there's another pair. So the random variable is 22.5, but it occurs 2 times out of 9. And 39 and 44.5. So how do we calculate our expected value? The expected value is going to be calculated by taking each one of these random variables and multiplying them times the probability of their occurrence. There are 9 possible occurrences, 36 happens twice, so 2 out of 9, or 2 divided by 9, is the probability of 36 occurring. Same for 27. 1 out of 9 is the probability of 19 happening. So here's our probability. I've set up a table for you. Here's the outcome. And you know that the expected value is a multiplication, again, of the outcome and the expected and the probability of that outcome summed together. By the way, all of these probabilities must sum to 1. Otherwise, we haven't counted something or overcounted something. So here I do a calculation where I say multiply 19 times 0.111, and I get 2.11, that's E35 times E36. I do that for all of these, and I sum them. That's my expected value. Here is a second calculation that you could do with a very nifty little function in Excel that's called sum product. Sum product takes a vector of numbers, a row of numbers, and multiplies it by another row. The rows must be the same length. So that says take what's in here, in this row, multiply it times this row, and then sum it. And by the way, we get exactly the same answer. All right, let's go to problem 2. In this particular problem, we are asking a question about a conditional probability. We've collected data, 12 observations, scant data, not a lot, but important data to us, and we feel that this is representative of the population. So we're going to make a leap from this scant data to the population. The question is, what is the probability that given you have someone that is college educated, that person will be a female? One way to do that is to simply count things. But if this were a large table, that would be impossible. All of the college educated people, and then try to determine the number that were also female there. So what we want is a general approach to doing this analysis, and pivot tables allow us to do that. I'm going to create a pivot table for this data. I've done so here, by the way, and this is a picture that you see here. By the way, you can copy something and copy it as a picture, and it moves around. You can't actually get into it, but it's just a picture of what's happening. This is what I'm shooting to get. So let's grab our data again. Now grab the observations. Let's then go to Insert, Pivot Table, let's go to, in a existing worksheet, let's put it down here, hit OK, and my table opens up, and you can see from the table here that on the right I can begin to fill in the areas of the table. I'm going to put, I want what? I want gender in columns, I told you that, and I want education here. I can put any of these variables in the values. We don't have any values. We're just going to count occurrences. So I'm going to put a count here, and here's what I get. I hate the lack of neatness in this particular way of developing these tables. I like to center everything. I'm compulsive. So what we see here is that 2 of the transactions were male in college, 5 were college and female, et cetera, et cetera, et cetera. There are 7 total college and there are 5 female. Right away we could do that calculation. But I can also do the calculation by going to right-click in the table, going to show values as percent of row total. The row total is the number of college students. And so here's 100% of our college students. Of those college students, 71.43% happen to be females. Really very clever use of pivot tables. And if you have a lot of data, this is going to make a lot of sense. Okay? We could have done this analysis just by those counts that we saw on the table by hand, but this does it very nicely for us. Okay, that's the end of the first 2 problems in module